Okay. Can we call init containers as sidecar containers? No. Sidecar and main car containers run all the time. Whereas init containers will start and they will be stopped. Okay. So yesterday I think we have tried to understand what a namespace is, what a pod is, right? What a replication controller is, and what a daemon set is. Any doubts on this first? Because yesterday we didn't have time to discuss on the doubts. Then I'll get into the next set of controllers. Does the default restart policy maintains the desired state? No. Default desired policy is not for a maintained state. Default desired policy defines what pod does when your container is terminated. Okay. Will container keep trying or will it stay quiet? Will container keep trying or will it stay quiet? So restart policy has an impact on pod's life cycle. That's it. Please explain one more time API resources. See, API resources is in Kubernetes we have lot of objects. Okay, and Kubernetes is exposed as a REST API. Okay, you and me use a kubectl which will internally make a REST call to the same thing. Right. So what are the different resources that are available in Kubernetes is what an API resources. Okay, so in that we see a section called as namespace, which has true or false. Okay, for whatever resources where the namespaced value is true, that means that they can be existing within a namespace. For whatever values which are not namespace, they don't come under the boundary of namespace. So for example, yesterday we have seen two things, node and pod. For the node API resource, the value of namespace was false. For the resource pod, the namespace was true. So a pod can belong to a namespace, whereas node cannot belong to a namespace. Node is a global entity, which is basically present to a Kubernetes cluster, not to a namespace. And namespace was a virtual cluster. This is basically what it means. Okay. Namespace is an isolated area. No, sir. Namespace is a virtual cluster. Okay. That is a Linux namespace which you are trying to see. Okay, here I am trying to speak about Kubernetes namespace. అన్ని పదాలకి ఒకటే మీనింగ్ ఉండవు. ఓకే, చెప్పు అంటే అర్థం ఏంటి? ఫస్ట్ మొత్తం పదం చెప్పు, ఆ తర్వాత నేను చెప్తాను చెప్పుకి అర్థం ఏంటో అని. అవునా? Right? Some words might have multiple meanings. So in here we are speaking about two namespaces. Right? The first namespace which we have discussed in Docker was the Linux kernel namespace, which speaks about isolations. Here we are speaking about Kubernetes namespace, which speaks about virtual clusters. They have two different meanings, right? Okay. Right. Is init container run before? Yes, init container will run only before the execution of main container, and init containers cannot run forever. They should just run some command and they should come out. Okay, otherwise your container will never be running. That's the whole idea about it. Yeah. How to automate Kubernetes with Jenkins? How to automate anything with Jenkins? Forget about Kubernetes. Okay. Since you have asked this question, I'll ask you one more question. How did you automate Terraform using Kubernetes or using Jenkins? How did you automate Terraform using Jenkins? Veeranjaneli, go ahead. మీది నాది పరిచయం ఇప్పటిది కాదు. Okay. Right. Any tool, what? What will you do from Jenkins? What will you do from Jenkins? From Jenkins, I'll call the command line. Yes or no? From Jenkins, can't I call the kubectl command line? Yes or no? So is it not how Jenkins speak with Kubernetes? Right? Jenkins ki Kubernetes ki pedda ventaga emi jaragadu. It is the same thing. Like how you are integrating with any other tool, it's the same thing, right? From Jenkins, if you wanted to call Maven, you had to install Maven and then you had to execute from Jenkins MVN package. From Jenkins, if you wanted to basically run Ansible, you had to install Ansible on some node and then you had to call Ansible-playbook. Terraform, same story. Kubernetes, same story. From Jenkins, take a Jenkins node, try to install kubectl over there and call your kubectl commands from Jenkins. So how is it different? Yeah? Okay. Helm chart use. Okay, I'll start Helm charts. Let us stop Kubernetes. Okay? Kubernetes సరిపోయిందిగా అయితే. Let me start about Helm chart. Okay? I'm starting Helm chart. Go ahead, man. Let me do this. ఓకే, ఇవాళ హెల్మ్ చాట్ మాట్లాడతాను, రేపు ఓపెన్ షిఫ్ట్ మాట్లాడతాను. కుబర్నెటాస్ ఇస్ డన్. ఓకే, ఐఎమ్ క్వైట్ షూర్ దట్ వీ డోంట్ నీడ్ టు అండర్స్టాండ్ వాట్ ఎ పర్సిస్టెంట్ వాల్యూమ్ క్లెయిమ్ ఇస్, హౌ నెట్వర్కింగ్ వర్క్స్ ఇన్ కుబర్నెటాస్, రైట్? సో వేర్ టు లుక్ ఎట్ లాగ్స్, వాట్ ఈస్ ఆర్బ్యాక్ పాలసీ, ఆల్ ఆఫ్ దిస్ ఈజ్ ఓకే. హెల్మ్ చాట్స్ ఈజ్ ఇంపార్టెంట్, రైట్? లెట్ మీ స్టార్ట్ హెల్మ్ చాట్. ఒకసారి చేస్తే కానీ ఇంకోసారి ఇలాంటివి జరగవు. లెట్ మీ స్టార్ట్ హెల్మ్ చాట్స్ టుడే. ఓకే, yeah. If no is the answer, why the hell are you asking? Did I skip any topic till now? Right? Helm chart is the last thing. Anni vachesaka. Right? Helm chart is the last thing. For example, in Helm chart, you don't worry about Kubernetes. You worry about applications. Right? I want to deploy MySQL. So what Helm chart says is, why are you worrying about this persistent volume claims? Why are you worrying about this individual things? Let me give a high level overview of it. Then you write a Helm chart. Okay, right? So let us do the steps step by step, man. Okay, right? Yeah. How to communicate multiple pods in different clusters. Okay, I'll speak about that, but that discussion will come into play the moment we start something called as Kubernetes DNS component. Okay, but yesterday I've said that your namespace name has some implication on name of your services. Name on your services. Then when we speak about Kubernetes DNS component, we'll worry whether it is possible or whether it is not possible. Right? Okay. నేను ఇవాళ క్వశ్చన్లు అడగమంది మీ కోరికల గురించి కాదు, నిన్న జరిగిన క్లాసులో ఏమన్నా అర్థం అవ్వకపోతే అని. రైట్? ఇఫ్ ఐ స్కిప్డ్ ఎనీథింగ్ at the end of the class, I'll give you some time, then I'll try to discuss about it. For example, if I miss the day when I say that, okay, I finished Kubernetes, you can ask me anything. Okay, right? ఈసారి నుండి ఇదే రూల్. If someone asks something, I'll directly start that. Okay, yes. Okay, fine. So are we clear about what we have discussed yesterday? Yeah. So now we have to understand certain other components also. Well, let me go ahead and then okay. Okay. So what are the controls which we have discussed yesterday? Not this. Pods, yeah. We have discussed till daemon set, right? Okay. So okay. Stateful sets. I'll not write more about it. Okay. But what is state in any application? Remember, we have spoken about stateless applications. So what is a stateless application? Stateless గురించి మాట్లాడలేదా? Okay. So what is a stateless? ఒక్కళ్ళకి కూడా గుర్తులేదా? Okay. Storing the data. Will it store on its own or will it store at a different place? Stateless. అర్థం లేదండి నాకు. Stateless is So stateless will not store any data within itself. It will always try to store on a different, right? So stateless means it doesn't remember. There is no need for you to remember any data. Stateless applications means they don't require any special storage, because whenever they have to store, they will rely on an external system. So for example, your web server is storing all the data in the database server, all the logs in a log server. So that web server is actually not using any kind of storage. So these kind of applications are called as stateless applications, right? Why are we worrying about stateless and stateful separately in Docker? Because in Docker we have a problem. That problem is, whenever you try to store anything in Docker container, it will store on the topmost layer, which is read-write layer. And read-write layer will be disappeared whenever your container is deleted. If you want to preserve that, okay, then we have to do special things specially. That's where this notation of stateless and stateful comes into play. Okay. For stateless applications means we need not worry about volumes. Stateful applications means since there is some storage that is happening into the system, then I have to worry about storage. That means that I'll deal with volumes. So now he is trying to tell stateful sets. So what is the stateful set? Let us look into it. Okay. Right. So I'm not getting into all the different stuffs of it. Okay. Right. Stateful sets. Okay. Give you an advantage, saying that when you create a stateful set, what it is trying to tell is, unlike the other things, for yesterday we have discussed the replica set. Yesterday we have spoken about replica controller. We have spoken about daemon set. Okay. Replica set and daemon set don't come with speciality about anything about Docker volumes. It doesn't speak about storage. Whereas stateful sets, what they speak about is, they speak about that shared volume. They speak about shared volume. So what do I mean by stateful set is, let us assume that I am running some database server. Okay. So my database server will do something with respect to storage. Yes or no? That means that it is a stateful application. So whenever it is a stateful application, I have to worry about volumes, which means I need to do some extra steps. That stateful set will basically allow me to do that, okay, by giving some of the features around it. So stateful sets, okay, speak about persistent storage, which replication controllers or daemon sets don't speak about. Okay. So whenever you are using stateful set, that means that you are in this stateful set, you are trying to run pods. That pods will have some Docker containers, and those Docker containers need some kind of a Docker volume. Need some kind of a Docker volume because you have to preserve the data. So in Kubernetes, if I want to run any container, okay, which has something to do with storing the data, okay, stateful set is one of the better option to go with that. Okay. And it has all the features. It has all the features of scaling, scaling up, scaling down. You will get all of that. And in addition to that, you will also get some storage related assistance. So stateful set, okay, if you look at the stateful set, okay, are you saying there is something called as volume mounts and volume claim templates? We might not know what this is, but is there something inbuilt into this? Yeah. So for easier understanding, we'll make this assumption. This is not actually right. Okay. Stateful sets, okay, are much like replication controllers, okay, with storage, or to be very specific, persistent storage. Okay. Am I clear on this? There are some conditions apply there. I am not getting into that conditions apply right now. So in replication controller, what is that we are speaking about? We are speaking about number of pods. So Whenever you are writing any object in Kubernetes, we have look through the spec. Every object will have API version, it will have kind, it will have some metadata, and then it will have some kind of specification. Okay. So in the specification of replication controller, I'll only speak about that number. Okay. Then I'll speak about what is the information about a pod. In the specification of daemon set, I'll basically speak about what does a pod sound like, because in daemon set, on every node on your cluster, this pod is running. Okay. Similarly, when I speak about stateful set, I'll speak about what pod I want. Okay. I might speak about number of pods, right? But definitely I'll also speak about volumes that are attached to your pod, which I'll not speak generally in the cases of other pods, because I have to deal them separately. Am I clear on this? Okay. So this is like for today, take it in this way. Replication controller and stateful sets are same. The only difference is replication controller by default doesn't have any idea about volumes, whereas stateful set knows something about volumes. So what can stateful set help us is in, so for example, I have 10 pods which are running in stateful sets. They can all share one volume. They can all share one volume, and I can tell whether they can read, whether they can write, right? So whatever kind of volume, it gives me help for doing that. Am I clear on this? Yes. Okay. So why do we use stateful sets? Stateful sets we use for a pods which need some kind of storage. Right? Okay. Fine. There are other details also, but I'll come to that. Okay. I'll speak about deployments, but before I speak about deployments, I have to speak about jobs and cron jobs. Okay. So here we have jobs. So what is a job? Generally, why do we run a pod? We run a pod so that it has run for all the time. It will run all the time. But in some cases, okay, you might not want to run it all the time. You might want your pod to do some job and then stop. Okay. So for example, we all know about something called as batch jobs, right? Every day in your company after 12 o'clock, there is some kind of reconciliation that happens. Okay. So I'm not sure how many of you have done this, but whenever you do NEFT transfers, whenever you buy stocks, right, you will not get the mails or consolidation stuffs immediately. You will get by the end of the day. By the end of the day, you will get a mail from NSC. You will get a mail from bank, right? If you have done some foreign exchange, whatever it is. Why? These do not run on business times. They will be run whenever the user triggers it. They run for some time, they finish the job, and their life cycle is stopped. So whenever you want to run something inside the pods, which doesn't have a permanent lifetime, like a web server, like a DB server, but it is some code that has to execute, perform its job, and then die. Okay, that is the case where we'll be using jobs. Right? But these jobs have to be executed manually. That's where what Kubernetes has done is, it has given something called as cron jobs. For the people who come from Windows background, I am quite sure that you understand what a scheduled job is. Every day morning at 9 o'clock, I want to run this. So how do you do that? In the case of Windows, we create a scheduled job. In the case of Linux, we call the same thing as a cron job. So in the Kubernetes also, if you want to do some operation at some particular times or specifications, then we can go with a cron job. So what is a cron job? Okay. Cron job or cron job, okay, speaks about specification which will run some application. Okay, it might be an application which is written, or it might be a script, or it might be a code, whatever it is, okay, which will execute and finish. Okay, which will execute and finish. That is like send mails to all of my customers. That could be a job. So we'll start this job. That job will be executed. It will send mails to all of your customers. Job is finished. Okay. If you want to do something like that, then you can use job and cron job. Not very popular in the Kubernetes world, or not at least popular in the terms in the areas which you work. But there is a controller called as job and cron job. So if someone says that in Kubernetes every night at 12 o'clock, I want to do something. Can I do that? Yes, you have a cron job. Yeah, right? So these are the basic controllers, because here this controller, what is a controller? Controller doesn't speak about what has to be run generally, right? Because controller doesn't speak about basically individual items. It speaks about a larger perspective. It speaks about a larger perspective, right? So generally, whenever you're writing controller, always remember that. Okay, note. Okay, like any other Kubernetes object, controllers also have, what are they? Specification, which is spec, and then status. Am I clear on this? This is much like what happens in every other stuff. Okay. But the only difference is here the specification is more about controlling the objects or workloads. Okay. So what will they do? They define the workload. So to be very specific, okay, you can define the workload. That means that in replica set, I can define what pod I have to run. Okay. Can define workload. Okay. Or it might not be necessary for me to define a workload. It depends on what is the situation which you're in, right? And how to run the workload, or to be very specific, how to manage the workload. Should I run 2? Should I run 3? Should I run on this node? Should I run on that node? All of that, it will try to speak about it. Am I clear on this? Yes. So workload controllers are basically what we would write. Okay, we have not written about a most important controller still, because before that I have to speak about one more workload. Before that I have to speak about one more workload, and then we'll get into the most important workload, which is deployment. Okay. So am I clear on this so far? So what will controller do? A controller will have specification. In that specification, they speak about workload, and they speak about what is that they are going to do to manage this workload. For example, if I say replication controller obviously manages the state. What is the state of it? Okay, state is the number. How many pods do you want to run? Okay, daemon set obviously speaks about pod. Which pod has to run? All right. How will it control it? It will control it in a way saying that, okay, on every node on your Kubernetes cluster, this pod will be running. Okay, if a new node comes, you don't need to do anything special. It will automatically launch it for you. That is what the daemon set does. When we speak about stateful set speaks about, okay, much like replication controller, and it will also say that since you are running these many things, I will also provide some kind of volume for it, which you can share among your pods. So for example, if I have 10 pods which are running Jenkins, right? So I can share some volume across all of these Jenkins pods. So I can do something like that. That is what a stateful set speaks about. Okay. When I speak about a job will create a pod. Pod will basically run some job inside that. Okay. Right. So it will track the execution of it from start to finish. Cron job will not only execute whatever you are trying to tell, but it will also know when to execute that. Okay. So these controllers are controlling the behavior of your workloads. That is a basic entity, right? So out of all of this, I'm quite sure that you should know what a replication controller is. There is one more thing called as replica set. Okay. So let me speak about replica set. Replica set. Okay. So replica set, much like replication control, there is no difference. Okay. So why do we use replica set and why do we use replication controller? There is literally no difference. Okay. So in replication controller, you tell that I want 4 pods to be running. In replica set also you tell the 4 pods to be running. Okay. But replica set has one property. Replica set can be preserved and revisited. Don't worry about this term. I'll be speaking about deployment today. And when I speak about deployment today, I'll come back to this. The second step, whatever I've written, please ignore that as of this moment. Okay. Let me speak about service. After service, I'll speak about deployment. When I speak about deployment, I'll revisit the replica set. Okay. So as of now, replica set and replication controller on this moment has no differences. Okay. There is one simple difference, but to understand that simple difference, we need to understand two more concepts of Kubernetes. Clear on this? Okay. Right. Now let us go to the stuff. ఈ పాట బానే ఉందిగా ఇలాగే చేసేద్దాం ఓకే రైట్ సో నౌ లెట్ us assume that I am not drawing nodes, I am just directly drawing pods. Is that okay? Yes. Okay, so I have a pod. Okay, so this is my pod. Okay, let us assume that I have one pod. I have one pod. So in this pod I'll be running I'm directly drawing the application images, but I assume that those applications are running inside the containers. Is that okay? Yes. So I'll put a Tomcat icon because it is easier to understand. Yeah. Okay. So when I'm drawing in here, it doesn't mean that Tomcat is directly running inside the pod. And understand that Tomcat container is something which is running inside the pod. Okay. So for this pod, I'll have some kind of an IP address. Okay. Let me call that IP address is 192.168.10.11. Okay. So this is running on a node. Okay. On that node, we will have some IP address. If I want to access this Tomcat container, remember in Docker we did -p8080:8080. We'll do something like that to access this application, right? So at least at this moment, that should be your assumption, right? So, and along with this Tomcat container, what I have is I have okay, I have okay. Oh, this is okay. So let us assume that I have a MySQL, and when I have a MySQL, obviously when I have MySQL, obviously it will also have some IP address 192.168.10.99 something like this. Okay, right? And it might have a name also. I'm just writing IP addresses. That doesn't mean that they don't have names. They have names also, right? Okay, right. So name will have something to do with the pod name over there, right? Okay. So now for my application to work, there should be communication between this Tomcat and database. Do you all agree with me on this? Yeah. Yes. For my application to work, I need to have stuff. Okay. Now this is a case. Okay. Let me write that. Okay. Okay. Consider this scenario where we have app server and DB server. Okay. Okay. And in this app server will communicate with DB server, okay, to store or retrieve the data. Okay, so let me save this image first. Let me put it now. Okay, right. All right, let us save this. So cube6.png ఇప్పుడు రాసి ఓపిక నాకు లేదు కానీ ఇది కాపీ చేసేస్తే యా సో am I clear on this? So this is our first case. Now after that what has happened was, okay, your requirements have increased, and basically what has happened is in the replication controller, using something like replication controller, you have said that, okay, now the count of my services my pods have to be 2 or 3. Yes. Okay. So our second case is we have scaled our application server. No problem. So far, is there any problem? So all the 3 will speak to the same database on whatever IP address that is basically mentioned, and there is only one thing which I have to do over here. Okay, just to make it simple. Okay, okay, okay. Okay, fine. That is the best thing which I could do, man. I can't. Right. Okay. So let us assume that we have these IP addresses. Now our Tomcat servers are basically running, and then they are all speaking with the database. Okay. So this is our second case. So okay, cube 7. Okay. So now due to application load, okay, you have scaled pods, okay, to 3, whatever it is. Okay, 3 or 300 for me. The story doesn't change from here. Okay, so are we clear? Can we do this with the replication controller? Yes or no? In replication controller, what does it speak about? It speaks about number of pods. Whether it is replication controller or replica set, I can do this. Yes or no? Because in the replication controller, I can basically tell what is the number of what is the pod and what is the number of pods which I want, and let us assume that I have scaled it to 3. Okay, and after that I have changed it to 3. I have just said kubectl apply -f some YAML dot something dot YAML. Okay, I've got 3 containers. Now let us assume this happens. Okay, this is also a replication controller or a stateful set. Okay, where you have said that I want one MySQL. This is dead now. When it is dead, what happens? We will get one more, right? Kubernetes pod. Okay, with మన ఇదేగా తీసుకుంది MySQL. Okay, and when we get the MySQL, we will get some IP address as well. So let us assume we got 192 168.10.88. Now what will happen to your application? Will it work or will it stop working? It will stop working because your database is no longer connecting. Yes or no? So can this arise in the Kubernetes situation? It might happen or not. Yes, it might happen. Okay, because controllers are speaking about how many Kubernetes pods do you want? Where do you want? Okay, but we have this problem with IP address. Yes or no? Okay, so now let's assume the node on which, okay, MySQL pod is running has failed. I'm not saying Kubernetes pod has failed. I'm saying node is removed from the network or node disk has crashed because our virtual machines can go wrong all the time. Okay. In that case, basically what happens? Okay. We get a new SQL pod. So let us assume, how will I get the same data? We know that there is something called as volumes, and volumes can bring in the data. There is no doubt about it. Volume chestnut. So you might ask also about data loss. Let us assume there is no data loss because let us assume we have used stateful set. Stateful set gives some kind of volume. So whatever data that was returned to MySQL is available on this container. Let us not worry about the data loss over here. Okay. But let us focus on the new SQL pod. Okay. Which comes with, which has new IP address. Okay. So now this is a story of it, right? Okay. So in this case, what happens? Your application will application stops working as DB is not connected. Okay. Yes or no? Okay. To resolve this, Kubernetes uses service. Kubernetes uses service. So let us try to understand how this service concept is used. Okay. Now, what Kubernetes basically does is, let me remove this. Let me go back to the older situation. Okay. Kubernetes tries to tell that, okay. Okay. Man, I have to do this nonsense again, is it? Awesome. There is a better way. Okay. Tapal. What was it? 110 and 112, right? One ten and మరి తప్పు చేసినా దొరకకూడదు కదా. Okay. Right. Okay then. So I have this situation. Okay. What Kubernetes tries to tell us, you can use something called as service. So when we add a Kubernetes service, basically what happens is, okay, let me try to, what can I do over here? I have to use a better use of real estate now. Okay, right. So what Kubernetes tells is, you can create something called as, okay, okay, MySQL service. What is that? MySQL service. Okay. And this service also will have some IP address 192.168.0. Okay. 234. Am I clear on this? So what is this? This is a Kubernetes service. Okay. So, and now if you want to speak with database, okay, rather than speaking with the pod directly, what Kubernetes suggests you is go and speak with this service. Okay. And this service will forward your request to the. Am I clear on this? Okay. But how will MySQL service know that it has to go to that stuff? Okay. That is our next discussion. I'll speak about it. Okay. But for now, assume it somehow knows it. What is that somehow also we'll be covering today. Right. So, am I clear on this? Now, we use service. Okay. Which is used for communicating to the database pod. Okay. So now in this case, is our scenario at least now looking better? Okay. I'll also discuss about a failure. Okay. So which is cube 9. Okay. Now let's assume pod has failed and new MySQL pod is created. Okay. So what has happened? Here this has failed. Okay. And in this place, I don't want to draw this again. ఇంకో ఇమేజ్ ఉంది కదా దాని నుండి తీసేద్దాం అక్కడ స్క్రీన్ షాట్. నేను ఇన్నిసార్లు డ్రా చేయలేను, ఇప్పటికే సహనాన్ని బాగా పరీక్షిస్తుంది. But we need those images, man. Images give you a better perspective. That's the reason why I'm drawing all of this. Classroom notes, DevOps, Jan, Kubernetes, images. Yeah, this was that image. Edit. I'll speak about what you can call it. Let me finish this discussion, because we not only need to understand what is this service doing, we also need to understand how this service is working first of all. Right? That defines one more Kubernetes aspect. Now we got it. Okay. In this case, your application is not speaking to this IP address anymore. And now, if MySQL can basically start speaking with this, is your problem resolved? Yes. And that happens. So your MySQL has failed. Okay, there is no IP address change. Your RDNS change. It is basically speaking with the same service, and in the background you have got a new MySQL. Okay, but it is getting that. But how does this stuff work? So when you create a MySQL service, what you do is you start using something called as labels. So now labels are much like your tags. So let me basically sticker icon. Let me use that. Okay. ఇవి కాదుగా మా స్కూల్లో మేము చదువుకున్నప్పుడు వాడే స్టిక్కర్లు వేరేలా ఉండేవి, స్క్వేర్ బ్రాకెట్ కలర్లోని. This is okay. This is okay, right? So I'm calling this as a label. So over here, I'll create this. This sticker lagi anipittaladu. Edi? Ida? 5 stickers. Price. Okay, we can do this. Tag icon. Yeah, this is fine, right? So we have in Kubernetes, we have something called as labels. So I'm trying to tell that, okay, create a label. Okay, this Kubernetes will service while I'm creating a service. I'm trying to tell that I have 2 labels. Oh, fine. I have 2 labels. I'll try to tell that in this label, I'll basically try to write app, okay, equals to db. Let me try to bold it, and let me try to reduce the font size to 12. 12 is too much small, right? But it will meet its purpose, man. That's okay. Okay. And then I'm creating one more label, which is called as version equals to 5.0. Am I clear on this? Okay. So we have 2 labels which we have created in the service, where we have said app equal to db, and then now what this service will do is it will go and ask etcd clusters, saying that in your cluster, give me all the pods which have a label called as app equal to db and then version equal to 5.0. It doesn't know what is running inside. What it will ask for? Give me all the pods in your cluster which are having a label called as app equals to. So now while creating your pods, what you have to do is you have to do the same thing now. You have to apply the okay. You have to apply the same tags. Okay, fine. What I'll do, I can't do much. ఇదేగా మనం తీసుకుంది. Okay, so rotate left 90. Okay, so rotate left 90. So I have 2 tags now. Okay, while I'm creating any new MySQL pod, I have to ensure that it has the same labels. So app equals to db and version equals to 5.2. Okay, here also we'll have app equal to db and version equal to 5.2. Now basically what is happening? Whenever you are creating pods, your pods will have tags. Okay. Now service will not know whether MySQL is running inside it or whether Tomcat is running inside it or whatever it is. Right? While creating a MySQL service, what is it you have said? I want, okay, to load balance, or I want to basically send the traffic to all the pods which have a label called as app equals to db and version equals to 5.2. This pod was killed, but immediately we'll get a new pod with the same set of labels, right? So now what MySQL service will do, it will send the traffic to the new pod. It will send the traffic to the new pod. Now even if this is killed and when we get a new pod, again that pod has to be created with a new label. So if you ensure that you are basically creating labels correctly, the service concept will work. Okay, but understand one thing, service will not know what is running inside your pod. It will just know what are the labels that are attached to your pod. So if you have given same pods to a Tomcat container, then it can send the traffic to the Tomcat container also, because it will not have any intelligence. Service will send traffic to the pods which match the label, So while you are creating a deployment, while you are creating pods, we should be creating something called as labels. Am I clear on this? Okay. So what I'll try to do is I'll try to save. Okay. Cube 10. Cube 10.png. Okay. So basically what is happening? When a service is created, okay, in the specification, okay, we are asked to provide, or okay, label information has to be provided. Kubernetes service will forward traffic, okay, to the pods matching the labels given in the service spec. Am I clear on this? Given in the service spec. Okay. So am I clear on this? Yeah. But when you use service, what you are doing is you are doing a layer 4 load balancing. Okay. Service is a layer 4 load balancer. Layer 4 load balancer means it knows about port and it knows about IP address. Port, protocol and IP address. Okay. So whenever you forward a traffic to that, you might also need to tell what is the port which will get the incoming traffic. So for example, in this case, you might tell that my incoming will be on 3306 port. I'll be sending the traffic out to the pods on a 306 because service knows about layer 4 load balancing. If you want to do the same thing on layer 7, which is HTTP, then we use something called as ingress. Okay. So in Kubernetes, okay, layer 7, okay, load balancing is supported by ingress. Okay. So layer 4 and layer 7 load balancing. Layer 4, remember that in computer networks you might have studied that layer 7 layers of ISO model, OSI model and all that stuff. In that, layer 4 speaks about port and protocols. Layer 7 speaks about an application layer which speaks about HTTP. So for example, in layer 7, you can write a rule saying that whenever user is requesting /admin, forward it to that. Whenever the user is asking /users, forward it to that. So layer 7 will have intelligence not only about port and protocols now, it has information about your URIs, HTTP URIs, మన website URLs ఉంటాయి కదా, it will understand that also. That is a layer 7 load balancing. Okay, right. So there is no need for you to worry about ingress at this moment. I have just written this point because what is the difference between Kubernetes service and Kubernetes ingress is the layer on which the load balancing happens. The layer on which the load balancing happens. Am I clear on this? Okay, right. Now, pardon me? 10, okay. Right. Fine. Now let me tell you one interesting stuff. Let us assume that we got a MySQL new version. We got a new version of MySQL. So, now what you have done is, you have taken this, okay. You have created this MySQL. Okay. ఇది ఇద్దరంతో పనే ఉంది, మనకి ఎలాగ చచ్చిపోయింది అన్నాక దీన్ని తీసేద్దాం ఆగండి. ఓకే. ఓకే. right? You have created a new version of MySQL. Okay, and let us assume that it got an IP address of 192.168.10.8. Okay, right. So, but this is a new version. This is a new version. So while creating this, what you have said is version value for the tag value was 5.0, right? You have changed it to 6.0. Now what will happen? You still have MySQL service where MySQL is sending the traffic to this. Now what you will do is you will go and remove this tag in the service definition. Now what will happen? It will ask Kubernetes, give me all the pods which have a tag called as app equal to db. And if you see, I have app equal to db here, I have app equal to db here, and I have some extra tags. Extra tags are not considered. So Kubernetes will suddenly start sending the traffic one time to here and one time to there. Okay. Now what I'll do is, okay, I'll change this version information. Okay. I'll change this version information from 5.0 to 6.0. Then what happens? My traffic will be sent to this, but it will be removed. Yes or no? So if you see, I have upgraded my pod. I have upgraded a version. Okay, and I am doing all of this without taking a downtime. I am doing all of this without taking a downtime. How? I am changing labels. And changing labels is not a downtime activity. Changing labels is not a downtime activity. Yes or no? Does it make sense? Okay. So this discussion we will take much forward when we speak about Kubernetes deployments. Kubernetes deployment. So when you create a Kubernetes deployment, understand you write something called as replica set in that, and then mostly, and then you will be using a service or a ingress depending on what you are trying to see. Since it was a MySQL, I have used a service. If my application which is exposing to the outside world is a HTTP application, I could have used ingress. That's it. Are we clear with this example? So what is the most important thing for service to work? A label. And label for a pod is written in metadata. If you remember, we have written a pod spec, and in that we have skipped the metadata, right? So whenever label is always a metadata information. Okay, right? Like label, we have something called as annotation also. Okay, but let us finish this label discussion and then we will get into that. So are we clear on how service is working now? Okay, so service will not know what it is. And by the way, service is not a pod. Service is not a pod. It is a rule created by your Kubernetes proxy, right? So it is not a pod that is running that IP address, because you might tell that, okay, what will happen if MySQL service goes down? MySQL service will never go down, because MySQL service is like a rule in a router now. MySQL service is like a rule in a router. Okay, MySQL service will have a different IP address in no case. Okay, the only case when MySQL service is not working is when your cluster is not working. Okay, because MySQL service is not a pod, it is a rule. It is a networking rule that is written in your Kubernetes networking component, saying that whenever the traffic is coming to 192.168.0.234, okay, on port 3306, forward the traffic to whatever pod's IP addresses which you are basically connected to. So this is not a service, is not a pod. So you cannot tell that, okay, what will happen if service will die? There is no chance that service is dying, because service is a logical component, not a concrete component like what a pod is. Clear on this? Okay. So service fail a chance. Okay. And then when we go to the next level, we'll try to understand. So if I want to expose this service to the outside world, can I do that? Yes, you can do that. Okay. So I can connect this service to Azure load balancer. I can connect this service to Amazon load balancer. I can connect this service to your F5 load balancer which your company is using. That is how people use Kubernetes. Once we learn all of the Kubernetes, the last thing which we do is your web application, which is swiggy.com, whatever is working, right? The service of Swiggy, the Kubernetes service of Swiggy will be connected to the external world, okay, by either by using whatever mechanism which your company wants, right? So I can tell that this MySQL service, okay, whatever I have will do load balancing using Azure load balancer, using AWS load balancer, or whatever load balancer which you want to, because Kubernetes service works with lot of load balancer components, lots of load balancer components. Clear on this? So that is while exposing to the outside world. Now we are speaking about Kubernetes within Kubernetes network. Are we clear about this? Yes? Okay. Right. So if you understand this concept, understanding deployment is also simple. If you understand this concept, understanding deployments is also simple. So what is one practice which we should start working with Kubernetes now? Whenever you are creating a pod, don't forget to create labels. Don't forget to create labels, because tomorrow you never know, you might start with one pod, but your application might end up becoming a huge hit, and then you might need to start to load balance. And whenever you want to do that, we need to take the help of pods. Pods along with labels. Labels add lot of value, okay, because labels help us in load balancing, okay. But as I said, if you don't understand labels, and if you give the same labels for Tomcat also, okay, పొరపాటుని ఏ label Tomcat ఇచ్చారనుకోండి, MySQL service will not know what is running inside, whether it is Tomcat or whether it will forward one packet to this and one time traffic to this. Okay, that can happen. So whenever you are creating labels, create labels very carefully and create meaningful labels. Don't create labels like X equal to 1, Y equal to 2. No. Right? Create labels in a way saying that they are meaningful to your application. Okay. So you might tell organization, what is your organization? What is a layer? Layer is a database. Which version of application are you working on? Right. So that is something which basically will be done. Clear on that? So from now on, whenever we are writing a specification, what is that we have to mandatorily write? Labels. We have to write mandatorily labels. When we created a pod for the first time and when we applied, we were not worried about all of this information. Right? But once we understand Kubernetes, we will understand about smaller things that come into play. Right? Fine then. So, right. Can label of a pod be changed and created anytime? You can change anything. Change it in your YAML file and then you do kubectl apply. Yes or no? Right? Kubectl apply whatever specification which you have run. You can run this as many times as you want. Okay? To change any information. All right. When I am creating a Ubuntu pod in the master, then it is not getting created. It shows crash loop back off. What does it means? Okay? That means that you are creating a Ubuntu pod. Okay. Okay. So in Ubuntu pod, what is there in CMD? When you run Ubuntu pod, what will happen? Forget about Kubernetes. Try to run a Ubuntu on a Docker container. Will it run? Yes. How? What will be your command? Docker container run. After that? Sleep one day, no, you are giving something because by default Ubuntu will not run, right? So what is that you are trying to do? You will try to give some CMD. Okay. Where did you give CMD to the container in this pod specification? You have to give that. You give that and try. Because what is happening is pod is trying to start Ubuntu. There is nothing in CMD. It is stopping. Yeah. That is what is happening. Okay. How does the communication get done? Because we are having 3 Tomcat pods and okay. You see, Tomcat le ela communicate avutundi annadi nenu vaalla maatladala. Tomcat database ela maatladutunnan, right? So on the top of Tomcat containers also we'll have one service which is Tomcat service. On the top of Tomcat also we'll have one service which is Tomcat service. Like how we had MySQL service, we'll be having an app service also. Yeah. Okay. Right. Okay. Please explain replication controller versus pod scaling. Okay, replication controller can help in pod scaling. Am I clear on that? Replication controller can help in pod scaling. Everything is versus. మనకి భారతదేశంలో న్యూస్లు చూసి ప్రతిదీ అలా అలవాటు అయిపోయింది. రైట్? ప్రతి దానికి గొడవలు పెట్టేస్తామని అన్ని వర్సెస్ కలిసి ఉండవా ఏమీని? రైట్? రైట్? ఓకే. రైట్. Everything is versus, man, these days. What is metadata? Metadata is an extra information about the pod, and label forms extra information about your pod. So that becomes a part of your metadata. Okay. Is init control run only before the actual container? Can it run parallelly also? If you want to run it parallel, we don't call it as init container, we call it as sidecar container. Okay, but init containers will be run before your actual container runs. Only after your init containers has finished the execution, your actual container will start. So they can't run in parallel. Okay, right. Let me see. How to communicate between different pods and different clusters? I think I've said that. When I'm creating a pod like Ubuntu, I think I've given that. Doesn't it store the data in the local system? Okay, right. Okay. You are trying to tell about stateless. Okay. In Kubernetes execution, 4 nodes and master cluster control is what is it? Executions. 4 node master cluster control the node or not. So what is that? What do you mean by that? Are you saying that you have 4 master nodes? Yeah, 4 master nodes will work, but having a odd number is a best practice. I'm not saying that 4 will not work. 4 will work. Okay. Right. Yeah. Can you tell me what is the difference between pods and nodes? Baboy. Right. Sir, I don't have that much of knowledge now. Right. What is the difference between node and pod? Seriously? Is this your first class? Okay. So if this is your first class, please go to the recordings of the previous classes. Right. Yesterday itself, I have said that this is a serial. రైట్, ఇవాళ అత్తే కోడల్ని ఎందుకు తిట్టిందని తెలుసుకోవాలంటే నిన్న ఏం జరిగిందో తెలియాలి. आज सास ने बहू को क्यों गाली दिया, अगर आपको पता करना है तो कल का एपिसोड देखना होगा. नहीं, सीधे आके आज का एपिसोड से कुछ भी नहीं होने वाला. राइट, so please listen to the whole classes. I don't have that patience to speak about what is difference between node and a pod at this moment, because we have been discussing about it. Is there anyone else in the room who has the same question? Right, node is your virtual machine, pod is where your container runs. Yes. Okay. In the case of stateful containers, no, not in the case of stateful containers. Service concept comes into play whenever you don't want to failure, you don't want to impact, a pod failure should not impact your system. If that is the case, then service comes into play. So for example, in the case of MySQL, we had only one pod. Okay, but failure of MySQL pod, we didn't want it to impact to our application. So what is that we have done? We have created a service. Right. Okay. Right. How do you know services know new SQL IP address? I didn't got. How do I know? My knowledge doesn't have anything to do with Kubernetes. Today I think I have spoken about how Kubernetes is working. Right. మోహన్ రెడ్డి గారు, సార్ మొన్న చెప్పాను కదండి ఫోన్లో, ఇన్నిసార్లు టైప్ ఎందుకు చేస్తారు సార్ ఇది? రైట్, నాకు ఏదన్నా సగం చదవటమే చిరాకు. మీరు రాసిందే రాసి ఇన్నిసార్లు పద్యాల్లోకి రాస్తే నా వల్ల ఓపిక లేదండి నాకు. రైట్, చెప్పి రోజుకు 10 సార్లు మీరు 100 సార్లు రాసేస్తున్నారండి. జర్నలిస్ట్ గా ఏమైనా ట్రై చేశారా సార్ మీరు? రైట్. ఓకే. Ingress is equal to inbound. Ingress is equal to, in the case of Kubernetes, ingress is a layer 7 load balancer. Right? In the networking terms, you call ingress as inbound. I know that. But in Kubernetes, ingress means layer 7 load balancing. Okay. In MySQL service, do you need to create tags? They are not called as tags. They are called as labels. They are called as labels. Okay. So when a new version is updated, whether the old version pod will be automatically deleted? No. If you want to automatically delete, you have to attend tomorrow's class. Okay. ఇప్పుడు నేను కూడా అలా సీరియల్లో ఈ జీటీవీ తెలుగులో యాడ్లు వస్తాయి కదా, రేడియోలో వింటున్నప్పుడు అలా చెప్పుకోవాల్సి వస్తుంది. రైట్. యా. గాయత్రి చేసిన అన్యాయాలని తులసి ఎలా కాపాడిందో తెలుసుకోవాలంటే రేపటి ధారావాహిక చూడండి అని ఇలాగే ఏమన్నా చెప్పాలి నేను. Okay. Tarvai bhagam చూడండి. Yes. Yeah. Why you didn't created labels for Tomcat? I have not created labels for anything. I am just explaining this concept. Tomcat also will need labels if you had to come under service. Right? Okay. So Rupini, today I was just trying to explain the underneath layer. So my focus was not really on how people will access Tomcat. My focus was on how Tomcat will access MySQL. Right? When we will get into deployments tomorrow, we'll speak about this whole application. Tomcat being accessed and MySQL being accessed. Then we will have one more layer on top of this Tomcat. Okay? ఇక్కడ అంటే మీరు అనుకున్నంత ఫాస్ట్ గా నేను ఇక్కడ బొమ్మలు గీలేను కాబట్టి ఆ తప్పు జరిగిపోయింది. రైట్? ఓకే. ఫైన్, మన రెస్ట్ ఆఫ్ ద క్వశ్చన్ ఐ ఆన్సర్ ఇట్ టుమారో. రైట్? సార్ మీరు కొంచెం తక్కువ టైప్ చేయండి, మీ వల్ల మిగతా వాళ్ళ ప్రశ్నలు స్కిప్ అవుతున్నాయి. నాకు బద్ధకం చాలా ఎక్కువ అసలే. So that's the whole point. So please don't type too many questions also. First of all, see, if you think that you are the most laziest person, no, I am the best there. Right? So I'm the best there. So don't do that. If you have anything important, please ask me. Okay, don't type anything. Mohan Reddy garu meeku దయచేసి వేడుకుంటున్నాను, నా ఫోన్ నెంబర్ ఇస్తాను మీకు. ఓకే, రైట్. అండ్ నేను మన క్లాస్ లో కూడా చెప్పాను, మీకు అనుమానం ఉండటంలో తప్పు లేదు. కాకపోతే ఒక్కసారి టైప్ చేసినా నేను సమాధానం చెప్తాను. ఇలా 100 సార్లు టైప్ చేస్తేనే చిరాకు వస్తుంది. రైట్? ఓకే దెన్, థ్యాంక్స్.